the real economic promise of drones is the ability to have a number of robotic aircraft doing a job for you without you having to fly them. And that implies that the ratio of operators to aircraft starts to look like one operator to many aircraft. So being able to literally not watch the airspace around the drone means you can start to flip this ratio over the right way.
You're listening to the Drone Radio Show podcast, the show about drones and the people who use them for business, fun, and research. Hosted by Randy Goers.
Hello, everyone. This is Randy Goers, and welcome to the Drone Radio Show podcast, episode 299. Can machine learning advance beyond visual line of sight operations? One company knows that it does. Iris Automation is a safety avionics technology company pioneering detect and avoid systems and services that enable customers to build scalable beyond visual line of sight operations. Their cutting-edge software uses machine learning and computer vision to continually fine-tune its capabilities and integrates easily onboard unmanned aircraft systems. This allows the vehicles to fly safely at long distances and without human intervention. Jon Damush is CEO of Iris Automation. He has over 30 years of aviation technology experience and executive leadership, building upon his background in engineering, software development, and systems integration. Most recently, he led new business ventures at Boeing NeXT. Before that, he was Chief Growth Officer at Insitu, a Boeing subsidiary developing novel aircraft and UAS innovation, including detect and avoid. He was also a Boeing executive liaison and board observer to SkyGrid, a joint venture between Boeing and SparkCognition. James Howard is the company's Vice President of Engineering. He's a mechatronics engineer, roboticist, and entrepreneur. James worked at Boeing and Insitu Pacific on computer vision research for drones, such as the ScanEagle. At Spire Global, he helped build and launch their first 4 commercial satellites, seeing firsthand the insides of successful, highly technical aerospace startups. In this edition of the Drone Radio Show, Jon and James talk about Iris Automation, the company's innovative Cassia detect and avoid technology, and how machine learning can help make the sky safer for UAS operations. But before we hear from Jon and James, I want to thank those of you who are supporting my funding campaign. Whether it's $1, $100, or much more, you can help defray the cost of production and keep the podcast going and growing. Go to droneradioshow.com/donate. And by the way, if you have an idea for a great show and want to share your expertise, please contact me at randy@droneradioshow.com. So let's find out how machine learning is advancing beyond visual line of sight operations with Jon Damush and James Howard of Iris Automation. Let's pick up the interview where I asked Jon and James to introduce themselves.
Jon Damush. I'm the rather newly minted Chief Executive Officer of Iris Automation. I joined the company on October 5th. Prior to that, I was the Senior Director in charge of new business ventures for Boeing's innovation team called Boeing NeXT. I was there for 2 years. Prior to that, I was the Chief Growth Officer for a wholly owned Boeing subsidiary called Insitu Incorporated, which is Boeing's large drone business, primarily focused on defense. And then just prior to that, I ran a startup company called 2D3 Sensing, which was a company that used computer vision to help full motion video analysts produce intelligence reports from airborne platforms more quickly and more accurately using a combination of computer vision and kind of commercially available software development techniques. We ended up selling that business to Boeing, which is how I ended up at Insitu, and Insitu is how I ended up at Boeing. And I ended up at Iris because I've been watching the company and saw what it was doing, and it was addressing a really, really key part of the value chain of unpiloted systems, and thought this would be an amazing way to combine my prior startup experience with my passion for aviation and really go try to make a difference.
My name is James Howard. I'm the co-founder of Iris Automation and vice president of engineering. I lead the technology development of our product, Cassia, and really built the company to address a fundamental need of the unmanned aviation space. And that was the ability for unmanned aircraft or autonomous aircraft to see their environment and interact with their environment in a way that piloted aircraft do, and to enhance the safety of unmanned aircraft. And that came from experiences that I and my co-founder had in previous drone companies. And I worked for a short while at Insitu as well, actually, as Jon, and really recognized through that experience and others that the unmanned aircraft space was missing a critical piece of technology, and that there was room to develop that technology. And that's where Iris Automation came from. And now for the last just over 5 years have been building the technology, building the company, and developing Cassia into what it is today and what it will continue to expand into in the future within aviation.
Tell us about the company and what it's trying to achieve.
So Iris Automation was founded to solve the problem of unmanned aircraft potentially colliding with other aircraft in the airspace, where piloted aircraft have a pilot whose job it is to maintain the safety of the flight that they're performing, where unmanned aircraft rely on people on the ground to perform that function. And part of the allure of unmanned systems is their potential scalability with automation. And the reliance on people performing these safety functions was a fundamental flaw in that. And we developed Iris to enable these autonomous systems, these robotic aircraft, to be able to perceive their environment themselves and to start developing the automation in a much more advanced way than what it had been done in the past. And so our technology uses computer vision on board the aircraft to be able to detect other aircraft near where that drone is operating, so that that drone has awareness of its airspace and can make intelligent decisions about its behavior and about the operation that it's involved in, to be able to maintain safety of that operation in an autonomous fashion and to improve safety over longer distances or more challenging environments or in different use cases.
Jon, is that what you were talking about when you said the company was developing something innovative?
Yeah. So, because I had prior background in computer vision, I knew exactly what the strengths and weaknesses of a computer vision based approach were. And, one of the critical ones is the fact that with a single camera system, as a matter of fact, I can use the human being as a great analog to this. We have two eyes, and presumably the reason you have two eyes is so that you can judge the depth to something, because you use the triangulation of your two eyes and your brain does the math to figure out how far away something is. But that's actually only good out to about 16 feet in front of you, because the baseline between your eyes is not wide enough to give you enough angular measurement to have a good accuracy of depth beyond about 16 feet. So the way you typically judge how far away something is when you're just looking at it as a human, you don't even know you're doing it, but you actually move your head side to side and you try to create additional baseline to judge that distance. So this has always been one of the Achilles heels of single camera computer vision, is that with one camera, you can't judge the distance well enough. But when you have a moving camera, you can, because now you can take two samples from the same camera over time and use that delta of angular measure to determine distance. But what Iris did was one step more, and they applied a machine learning approach to classify the targets that are in the field of view. And through that classification can now derive the type of air vehicle that you're looking at. And based on the type, because we know the size of that type of air vehicle and we know the geometry of our camera systems, we can infer distance. So it's incredibly novel and it's not easy to do. And they were able to do that. So when I, first heard of Iris, I was working at Boeing, and this was kind of, late 2018. And, as you typically do from a large firm looking at a startup coming into a really hard space, you're like, oh, okay, cool, novel idea, good luck. And as they started to get traction last year, and especially under the FAA's IPP program, it became pretty clear that they were onto something. And the fact that they had gotten the attention of the FAA and not only gotten onto an IPP program, but actually got some success. They got an approval to go operate as part of the safety system. That was kind of a raise your eyebrows moment for me specifically, because I knew the challenges of computer vision, but I saw what they had accomplished, and it was like, aha, somebody has kind of cracked the nut. So, I would say first and foremost, James, thank you for plowing through those times where it must have seemed incredibly impossible to make that stuff work, because they've succeeded. And now we're going to start turning the crank and expanding our capability set so we can start to address more of that last line of defense for collision avoidance. And I use that term deliberately, Randy, because I think it's important that your listeners understand that when it comes to safe flight operations, there is never a single technology that basically makes flying safe. It's always a layer of multiple capabilities that turn into a safe operation, right? You mitigate risk with each layer of mitigation that you have in place. So if you think about collision avoidance, well, it starts when you start planning your flight, literally on a map, and you figure out the 2 points you want to fly between, or the area you just want to go fly because you're going to do some photography. And you look at the airspace around you, you look at airports around you, you take a guess as to what kind of traffic is going to be there, and you plan your flight accordingly to minimize the risk of any collision. But then there's a whole bunch of other things that come into play. Airspace classes that restrict or grant access based on equipage, pilot certification, flight conditions in terms of the environment. Then there's other technologies like transponders and radar and ADS-B. There are services available from air traffic control. So you start to layer all these things together. And when you look at the piloted aviation world, as James rightly pointed out, the pilot's job is to be the last line of defense. All of those mitigations take away the majority of the risks, but the pilot is there in case something gets through, and therefore now can turn the airplane and avoid whatever that collision hazard is. That is kind of where we're starting our focus in a true crawl, walk, run approach. Let's try to provide a level of capability that gives the operator the comfort that they're not going to have a midair collision. Will that satisfy all of the emerging standards that are coming out and all the discussion around well clear and near midair collision avoidance? Probably not in its first go, but it's a start. And then we go from that position and we start to iterate and add more capabilities and explore more use cases to get to a point where the community is comfortable that, hey, this system actually works in a wide variety of use cases, and everybody should have one of these, because at a very minimum, it's going to allow you to bring your airplane and your payload home. So that's kind of how I view it, really, is that we're a critical part of the safety value chain, and we're doing it in a way by using computer vision that actually aligns really well with the current regs on the books, because the current reg 91113B literally says it's the pilot's responsibility to see. The word see is actually used, and avoid. And the beauty of a vision system is you can characterize that performance in a very congruent way with that word.
Just so I understand it correctly, is the system basically matching an image and size of a drone to something that it's already learned?
Generally, I think you're on. One couple corrections, and I'll let James answer the more technical specifics. But one thing to understand is that the risk that is most prevalent in limiting the beyond visual line of sight flight is the risk of what we call the non-cooperative intruder. And don't take non-cooperative to mean illegal. It just means that they're not sharing their information with our system in the same way that another airplane might. So here's the example. Let's take drones out of the equation for a second. Let's just say I'm going to fly my Cessna from Phoenix to Dallas. I'm going to fly mostly over New Mexico. It's pretty territory, so I'll fly at lower altitude. And most of that airspace is what's referred to as uncontrolled airspace. To be specific, it's mostly Class Golf, Class G airspace. Well, in Class G airspace, you don't need to file a flight plan. You don't need to fly on instruments. You don't need to have a transponder. There is no radar out there, and you don't need to have ADS-B. You could literally have a fabric-covered Piper Cub in your garage, and on Saturday morning, you just decide you want to go flying. So you're up there flying in a completely legal way, but you're not actually telling anybody where you are. So along I come in my Cessna, transiting that same airspace. The only tool I have available to avoid a collision is me looking out the window and I happen to see your bright yellow Cub. So that's the risk case that is probably the biggest limiter to seeing more widely adopted beyond visual line of sight flights today, is the non-cooperative intruder who's totally legal, but you need to identify and avoid somehow from your own airplane. If it's a human in the cockpit, we do it visually. The drone world is evaluating a number of different technologies to solve that problem. Our belief is that the visual approach is the right one for that use case. Over to you, James.
Yeah, you're asking, Randy, about how the system is able to recognize different types of aircraft. And we use a combination of different techniques. The system is fundamentally a computer vision system, but we also use techniques from artificial intelligence as well. And so it's less that the system stores samples of different types of aircraft and is trying to match to those, but more that we've actually taught it through a learning process from thousands and thousands and thousands of samples of aircraft, both from our real world testing, from simulation and other sources, about what different aircraft look like. So it has a more intuitive understanding about what it's seeing rather than just trying to match to a predetermined template or something like that. And from that, we can actually infer quite a lot of information about the aircraft that our system is seeing. We can determine the type of the aircraft. We can do things like estimating the range, the heading, and just get a more complete picture of what it is that's being seen, rather than just saying there is a plane-shaped object. We can infer more information about that object, and that helps us in giving a better situational awareness of the environment and the airspace around the drone.
Moving beyond detect and avoid, how does the technology enable beyond visual line of sight? What's the connection?
The current rules that are on the books, and this is pretty consistent globally, although the words they use and the regulation parts they use vary. But fundamentally, the only legal approach to flying your drone today for commercial purposes is under rules that pretty much say you always have to have the drone within your field of view. And that's less about you watching your own drone, and it's more about you watching the airspace around the drone to make sure that the helicopter comes through, a low-flying flight training aircraft comes through, you can get out of the way. So the rules kind of put a 400-foot bubble over your operations, and by definition then limit the number of use cases you can do with your drone for money. Basically, it limits it to mostly point inspection type of tasks. So things like flying a drone up to inspect a power tower or something like that, or doing, videography within a closed set, or perhaps wedding photography or real estate. So you can think about all of these use cases where it's really just about getting an aerial perspective, but in a rather small area. That Part 107, which is the US Federal Aviation part that governs small drone use, that's the limitations it puts on you. If you wanted to start doing something like inspecting a pipeline that spanned hundreds of miles, or inspecting or mapping a large area of terrain that, say, is hundreds of square miles, well, you're not going to put your drone in the truck and drive another mile and then go do it in that spot, and then bring it down and drive a mile and do it in that spot. You really want to cover that whole area with one flight. And by definition, you're going to have to do that beyond your visual line of sight. So that's one way it translates to beyond visual line of sight. The other way is that, and this is where I kind of don't like the acronym beyond visual line of sight, because it implies you're doing something far. But the real economic promise of drones is the ability to have a number of robotic aircraft doing a job for you without you having to fly them. And that implies that the ratio of operators to aircraft starts to look like one operator to many aircraft. The truth of drone operations today is we're still kind of at multiple operators to one aircraft. So being able to literally not watch the airspace around the drone means you can start to flip this ratio over the right way so that one operator can start to control multiple drones, or one operator sits on top of a system that's monitoring the operations of many, many drones. And they're doing that largely automatically. In order for you to do that, you still have to prove to the regulator that you're not going to crash into another airborne object. And to do that, you need some sort of technologies to allow you to make sure you're in safe airspace and you're not going to run into somebody.
The method and technology that Iris Automation uses to enable beyond visual line of sight, has that been accepted by the regulators?
I would say fairly accepted, as evidenced by the fact that we were able to get 2 waivers for approval from the FAA in the IPP program. But, that's not a blanket approval. Like, you can't just lift and place that and copy and paste it somewhere else and expect to just go fly. Those were granted, as a tip of the hat to say, well done, let's see how well this works in a real use case, but also to explore the use case in more depth, right? And that's really why I'm bullish in saying that generally I think we're aligned between us and the regulator and the way we're thinking about this problem, because they need to take an incremental approach. They need to try things to explore the real risks. Otherwise, you're trapped in the world of models that are, somewhat homogenous and not really detailed enough to be specific about your area of operation and your type of operation in terms of granting an approval. I would say, yeah, I think we're pretty well aligned in that approach and taking these incremental steps.
What's the name of the system and what is it comprised of?
So the product name is Cassia. So the company name is Iris Automation. The product name is Cassia. And within that product name, we have 2 main components. There's hardware and there's software. The hardware are for lack of a better way to describe it, call them smart cameras. And by smart cameras, meaning that they're optics, imagers, and compute capabilities that are tightly integrated with each other. Then we install our software on those smart cameras to do all of the magic that James described, right? The computer vision to detect and classify, the machine learning to classify and derive additional information, and then the geometries and the math that we need to do to provide the kind of intruder information to the mission computer and ultimately to the autopilot to effect an avoidance maneuver.
Are the cameras on the drone or is it a ground-based deployment?
They are on the drone. One of the reasons we've targeted that. Now, that said, we are exploring alternate deployments, but the primary thrust is to be the onboard vision system, because that allows us to tie directly into the autopilot system and minimize the amount of time needed to make a decision. And time is everything in a collision avoidance case. So the more time you can cut out of your processing loop, the better, because that gives you a better buffer around avoiding a collision. So we are on board today. Theoretically, there's nothing that limits the system from working in an off-board case, but that's not really been the focus of the company or our technology development to date.
How large are the cameras? Because on the website, at least for me, they look huge.
It's funny, when I first saw them in person, I went, oh, they're a lot smaller than I thought. It's because my basis of understanding was on the website, and they did appear to look a little bigger than they really are in real life. I don't know, James, what would you say, give Randy a scaler to help compare? What would be a good object that's pretty common that is roughly the size of one of our cameras?
Well, I think the camera and the Cassia system are sort of shown next to her. And Cassia, in terms of the compute module, because there's 2 parts to our system, is only slightly larger in footprint than like a credit card, for example. It's a lot thicker, obviously. There's the layers of electronics and other things in there. But hopefully that gives a good understanding of the scale that we're talking about.
One of our cameras would probably fit inside a baseball.
And then how many are typically equipped onto a UAV?
That's largely driven by use case. The waiver approvals we got under the IPP program were single camera systems, but again, that's closely tied to the operational use case that was being evaluated. it is pretty clear that in the US and globally, obviously, if you can see more, that's better. So if you can see all around your airplane in 360 degrees, that's better than only looking forward. So the number of cameras required to do that will vary by the aircraft configuration and design, because some airplanes are high wing, some are low wing, some have split tails, some have single tails, some are flying wings, right? So you really derive the number of cameras based on the configuration needed to see the amount of airspace that you need for the safety case.
Iris Automation was involved with 2 IPP programs. What were the objectives of the demonstrations?
Well, that predates me, so I'm going to ask James to jump in and answer that one for you.
So we've been involved in a number of different IPPs. I think the 2 that are, I guess, the most public are the Alaska IPP and the Kansas IPP. They were the 2 where we flew BVLOS demonstration missions. In both cases, they were for what we would classify as a linear infrastructure inspection. So that would be anything where you have a long piece of infrastructure all in a line. So railways, pipelines, power lines, roads, things like that. In the case of the Kansas IPP, we demonstrated a power line inspection with Westar Energy and the Kansas Department of Transportation. And in Alaska, it was with the Alyeska Pipeline Company, both demonstrating the use of autonomous aircraft to be able to perform long linear inspections of different types of infrastructure.
Jon, how long have you been the CEO of Iris Automation?
Since October 5th, so a whopping, 45 days.
Well, you've been with the company at least long enough to look around and see what's going on. Based on that, what do you see in the company? And more importantly, where do you want to take the company from this point on?
Yeah, I think, build on your strengths, right? And our strengths are very clearly this approach to computer vision, machine learning. And while our real value proposition is in the software, it would be remiss not to really highlight the fact that while we use a lot of commercial off-the-shelf components in our hardware, the design and the assembly and the integration of that hardware is pretty novel. So there's expertise in there. I think that's our strength. So building on that strength is continue to work with our customers, collaborate with the regulators to really push the boundaries of the envelope for BVLOS flight, but do it in a very incremental way. Okay, we learned what we learned last year in the IPPs through the FAA's Beyond program, of which we're a part. We're going to be investing time and resources and energy into taking the latest iterations of our hardware and software and putting them into real world use cases to push ourselves to see farther, to identify more objects, to constantly improve our accuracy, and then also integrate with a wider number of systems so that our customer base has a wider set of options available to them in terms of airplanes for the missions that they want to go accomplish.
That sounds like a good lead-in to the company's Regulatory Resource Center. Can you tell us about it?
Yeah, indeed. I mean, it's funny when you're trying to bring a new capability into a highly regulated field where the regs that describe that capability don't exist. You need to get pretty smart on regs because you need to be able to have a discussion with the regulator in their language and on their terms. So, whether we wanted to or not, we really had to build a regulatory capacity in our business. And through the process of getting involved in these trials and doing our technology development and liaising with the regulator, we have become one of the world's preeminent experts in this area of detect and avoid and BVLOS approvals for unmanned aircraft. So given that, you can immediately see why that would be valuable, not just to us, but to our customers as well. And the truth of the matter is, selfishly, it's good for us to help our customers be successful in the regulatory environment, because then that makes an easier path for them to adopt our technologies and use them on board. So, it's not completely altruistic, but there is a bit of the old cliche here, rising tide raises all boats. And therefore, we've kind of codified our expertise into this thing we call the Regulatory Resource Center, which is a combination of, knowledge base, best practices, and certainly human expertise that in some cases we provide certain elements of that to our customers as part of our engagement with them. In other cases, we package up specific statements of work as consultative services and provide them to our customers under contract. And then, strategically for us, that group of capabilities is not just to service customers. It's also to make sure that we are interacting with the standards bodies and the regulatory community as a partner and a collaborator, right? Which is, yes, we've got our IRIS badges on when we're in those meetings, but we're really trying to advance the state of the art in the community around BVLOS flight to use our learnings and our expertise to really kind of help the regulator and the standards communities approach something that's going to be repeatable and is going to be durable in time and, all without sacrificing safety. So that's really what the RRC is and the history of how it came about.
The proposed remote ID rule, what's your impression and how does the CASIA system fit into it?
In general, it's a good thing, right? Like all of us in this space are about unlocking the use of drones for real commercial scaled use cases. So remote ID, I'll paraphrase kind of the value I see in remote ID. It's obviously much more nuanced and specific than this, but it's effectively the equivalent of a digital license plate for your drone. And without that, you kind of have the Wild West. Incidents like the Gatwick Airport are a great example where someone, whether they were doing it for malintent or just didn't know what they were doing, they shut down a global international airport for a day. And the law enforcement agencies had absolutely no way to know whose drone that was, what they were doing, what their intentions were. So there's this kind of gap. Remote ID is a way to really, and it was driven from the law enforcement community, to, hey, just give us a tool so we know like who that is and what they're doing and are they doing the right things? Do we need to, interdict here or not? So I think it's a good thing. What it is not, though, and I think the community is pretty clear about this, but maybe the broader like drone community might not be, is it's not a tracking technology that allows us to do real-time deconfliction of aircraft. That's not what it's meant to do. It's meant to be a unique identifier on a drone so that there is traceability to the owner, the use, and law enforcement knows who's doing what. So James, over to you for any detail you might want to layer on there.
I think it's a clear indication from the regulator to say that the community needs to address issues that aren't just to do with can we make a drone fly a long distance or the actual use case, but to think more holistically about developing technology that fits into an aviation ecosystem. Specifically how that technology is implemented or what technology is used to solve those problems is kind of up to us, but it certainly sets that direction.
Is there anything that we missed that we should talk about?
What excites us about this business, and certainly excited me to join this business, is that this is not a drone business. This is an aviation safety business. And the capabilities that we're developing, while they're initially targeted at the drone market because they have this acute pain of not being able to fly without being able to mitigate collisions, the technologies that we're producing by no means are restricted to that segment. And as you look forward into the future of cargo aircraft, whether that's small drones all the way up to Boeing-sized aircraft, and then you look into passenger carrying aircraft, whether that's the dude in a jetpack or the air taxi Jetson style, or up to future generations of regional and, transcontinental travel, we are on a trend line in aviation that is about simplifying the human machine interface and increasing the smart use of automation. Everybody likes to throw around the word, autonomous. I would actually not use that word because that scares a lot of people in the regulatory environment, because it makes people think like it's the Cyberdyne Systems Model T101 Terminator that's thinking, right? Like that's not it. What it is about doing is using automation in a way that removes the burden from the human that has a direct benefit to the safety level of flight. And you don't have to look any further than the last 30 years of airline operations to see what the effect of increasing levels of automation have on safety. And it's directly correlated. So as airliners have improved their fly-by-wire systems, their flight management systems, their auto throttle systems, you see an increasing level of safety, and you also see an increasing level of capacity in the system. It wasn't so long ago that the rules changed to allow what they call reduced vertical separation minimums for airliners cruising at flight levels from 2,000 feet between them to 1,000 feet. Well, that's only enabled through the application of automation. So that's going to continue to happen. And our system sits squarely in the middle of that trend, because as you try to automate more, what you want to do is relieve the human of the tasks involved with flight today. And, I'm a commercial pilot and a flight instructor, so I spend a lot of time flying airplanes. And I'll tell you one thing, Rand, I'm terrible at seeing and avoiding other airplanes. Terrible. And the reason I'm terrible at it isn't because I have bad eyesight. It's because I have to do a bunch of other stuff, right? I've got to plan my flight. I've got to manage my systems. I've got to communicate with air traffic control. I got to fly the airplane. And oh, by the way, I still have to scan the atmosphere for other traffic. So my division of attention means I'm not always looking out the window. Matter of fact, probably less than I should be. A vision system like ours never stops. It's always looking, right? So I firmly believe with all of my heart that success in our endeavor leads to a higher degree of safety in aviation forever, because we're doing more for the human to improve the safety level of flying.
One thing to note is the novelty and difficulty of bringing a computer vision system to market in an aviation context. That no one has really done this before, and it's something that we as a company have figured out how to do, and we're really pushing the boundaries on that. And so I think it's impressive to see what our team has built and how that can continue developing within aviation, and really to see what the future of aviation is, whether that's manned or unmanned or a combination of both, or where this kind of technology, computer vision and AI and other technologies of its class, can enhance and further this industry.
That's an interesting point, James. If computer vision is an innovation, what are some of the more traditional approaches to sense and avoid?
A lot of what we see elsewhere in the market is approaches that are adaptations of existing technology. I think primarily what most people have seen to date is radar and the use of radar, which is a fairly well-established technology within aviation. It's used in many different contexts for many different purposes, but has fundamental limitations in its application to unmanned systems. And I think that's where seeing new technologies like computer vision starts to unlock capabilities that are otherwise not achievable because of a multitude of reasons. Like, it might be technical, it might be financial, it might be just the sheer size and weight of different things. And computer vision offers a new look at the way we solve these problems that can provide benefits in a lot of these areas, where image sensing technology is very cheap. It's also very lightweight and low power. And it sort of reshapes the problem into software as opposed to being purely a hardware problem, where it now becomes capable for us using the same sensing technology to continually improve performance over time through software updates, as opposed to needing to replace specific hardware with new generations. So I think there's a lot of opportunity for the use of newer technologies in aviation, not just in drone detect and avoid, but in the industry as a whole.
And for my final question, Jon, what message would you like to leave regarding the future of computer vision in the drone industry?
I would just build on what James just said. I think he hit the nail on the head, right? And that is, we see ourselves as a critical part of the safety value chain in aviation, but we'll also be the first to say that, while we have some strengths with a computer vision-based approach for all the reasons James just enumerated, we also recognize that there's complementary technologies, and it is our intention to continue to integrate and bring the best of breed approach together for our clients and for our regulators that maximize safety of any given operation. I think this is a marathon, not a sprint. We're in this for the long haul. We see tremendous opportunity for our business, and frankly, are just really motivated to be a part of the kind of the next century of flight and driving the safety level of aviation.
That's it for episode 299 of the Drone Radio Show. I hope you enjoyed hearing from Jon Damush and James Howard of Iris Automation. I want to thank Jon and James for taking the time to speak with me. If you want to learn more about Iris Automation or want to connect with Jon or James, check out the webpage at irisonboard.com. If you like the Drone Radio Show, please consider supporting the podcast with a small donation. The content is always free, but for as little as $1, you can help defray the cost of production. To donate, go to droneradioshow.com/donate. And thanks for listening. Your support means a lot to me, and I hope you'll listen to more episodes of the Drone Radio Show podcast to hear how others are using drones for business, fun, and research. For the Drone Radio Show, I'm Randy Gores.
This has been the Drone Radio Show podcast. More information on today's show can be found on our website at www.droneradioshow.com. If you're using drone technology for business, fun, or research and would like to share your experience on the show, please visit our website and fill out a guest appearance application. And don't forget to follow us on your favorite social media channels.